zCompute offers load balancers to allow you to optimize both for performance and availability. Each load balancer can be configured either as a network load balancer, which works with TCP sessions, or an application load balancer, which works with HTTP and HTTPS traffic. For this example, I've created two instances. Neither has an elastic IP, but both serve a basic HTTP web application on port 80. To create our new load balancer, we'll click Create and give it a name. Next, we select the type of load balancer, either a network load balancer for TCP sessions or an application load balancer for HTTP and HTTPS. We then select the VPC and subnet. For this example, we'll give it an elastic IP so it's accessible from outside the cluster, and we'll select a security group that allows ingress on the correct port. Load balancers can also be configured with managed security groups. When this option is selected, the load balancer will automatically open all ingress on the listening ports. Next, we select the instance type for our load balancer. We can scale this depending on the size of our expected load. We can also select the high availability option, which will create a standby load balancer that will step in case of any malfunction with the primary load balancer. The next step after creating a load balancer is to create a target group. A target group will define which systems to forward traffic to, which health checks to apply, and what protocols to use. We simply create a name, select a protocol. If we were using a network load balancer, we would select TCP, as well as the default port, and whether the session is sticky. While traffic will normally be routed to any one of the backend systems, sticky sessions can be used to ensure that the traffic from one client continues to be forwarded to the same backend system for the defined duration. On the next page, we define the health checks. This is how the load balancer will determine whether a target is healthy. In our case, we'll leave the defaults. Finally, it's time to define the targets. Targets can be defined either by instance or by IP. Now that we have both a load balancer and a target group, it's time to create a listener. Since we've created an application load balancer, we can select either an HTTP or an HTTPS listener. When we select the latter, we must provide it with a certificate. You'll see that the first rule created is a catch-all rule. It will apply if all other rules did not match the incoming request. Additional rules can be created, and these must have conditions applied. You can combine multiple conditions as needed. And then select actions. There are three types of actions. Forward will forward the traffic to a particular target group. Fixed response allows you to send a status code and optionally fixed content. And redirect, where we can define an HTTP redirect. For our simple example, we don't need an additional rule. We simply want to forward all traffic to our target group. The configuration of our simple example is now complete. If we send an HTTPS request on port 443 to the public IP of this load balancer, it will forward the traffic to one of the two targets in the target group. If we inspect the certificate, we can see the load balancer is serving the configured certificate. The zCompute UI only allows a listener to be configured with a single certificate. If you need to configure more than one certificate for a single listener, you'll need to use the AWS ELB API. More information about this can be found in our support center by searching for Managing Load Balancer Certificates. This information and more can be found under the Help menu at the top right.